Yeah. So what we discussed in the previous class, guys? That's what we discussed in the previous class. So we discussed about the Terraform variables and that stack. So how you can play the Terraform apply, and we discussed about the Terraform destroy also, right? The Terraform destroy with the hyphen target. So if you want, for example, you have a dev stack, right? Dev stack, QA stack, and product prod stack. So these stacks, so for example, in the dev stack, so we have a 10 EC2 instances. How many instances, guys? 10 EC2 instances. And so we have a VPC and so 50 SGs, security groups, and so 5 S3 buckets. So we have a, so this is your stack, guys. Your stack contains 10 EC2 instances. So how many? 10 EC2 instances and one VPC, 50 SGs, security groups, and 5 S3 buckets we have. So right. So in this code, if you apply Terraform destroy, so if you use the Terraform destroy, your entire infra will be destroy or remove. Right, remove, delete. Your entire infra will be delete. Right, the Terraform destroy, your entire infra will be destroying. So I don't want to destroy everything in my dev stack. So I want to destroy. I want to decommission. The terminology is the decommission, guys. So I want to decommission a two EC2 instances, two EC2 instances in my stack. So what is that? So how you can decommission, how you can destroy, or how you can terminate only those two instances, is it instances? Yeah. So we can terminate whatever we want in that stack on a particular instance or a particular resource, right? What we call it as EC2 instance is a resource, VPC is a resource, SG is a resource, S3 is a resource, right? The resources. So if you want to delete the resources, if you want to delete the a particular resources, so we can use the hyphen target is the hyphen target. So you can mention what is that AWS underscore instance. What is that? AWS underscore instance dot name of the instance. So for example, web1. So if you use this, it will terminate, it will destroy Terraform destroy hyphen target AWS underscore instance. So if you want to destroy the other one also, Terraform destroy hyphen target AWS underscore S3. The name of the S3 is something like my um, so 54 batch S3, for example, guys. So this is your name of the resource. So this is the resource name and the resource and the resource. So AWS underscore S3 underscore bucket dot resource name. So now you understood. So the Terraform destroy with a particular resource, or Terraform destroy with if you use the Terraform destroy, the entire infra will be destroying. So I don't want to destroy entire infra. So I want to destroy a particular service. How you can destroy it, guys? Now you understood. Yep, guys. So today we'll discuss about the Terraform mod. So what is that, guys? Terraform module. So does anyone knows what is Terraform module, guys? So I think Rajni, you know, right?
No,
Rajnikant,
sir, I don't. I don't.
you don't know. No?
Yes, I don't.
So what Terraform module is? Terraform module is something like it's a So, so what is Terraform module? Terraform module. So centralize, we can, we can centralize the Terraform resources, Terraform resources and can call out from TF. What is TF? Terraform files whenever, whenever required. So whenever required. So for example, paint. Yeah. So what is that, guys? We can centralized, we can centralize the Terraform resources. So you can centralize the Terraform resources and can call out from TF files whenever, whenever required, guys. Right? So what is that? So for example, what this is a source. And so what this is a Terraform. This is a module source, guys. What this is? This is a module source. So this is the module source. So whenever we required, so whenever, so we required, so this is the source. So this is the source. So for example, resource black, right? Resource. So what is the resource? AWS underscore instance. So what is the resource? AWS underscore instance. Web one is my resource, right? So web one is my resource. So here AMI equal to blah 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 blah, and instance underscore type equal to something as T2 micro or something like that. And so something like this is our code, right? So this is the source code. So when we centralize the Terraform resources and can we call out from the TF files? So whenever required, right? So Terraform modules. What this modules? For example, it is a skeleton. So we can use, we can create a skeleton for this. So for example, what the skeleton is? The skeleton is something like what is the AWS batch 54. So this is the AWS batch 54. So in the AWS batch 54, in the AWS batch 54, so you created a module called, what is that? Module, module called as, what is that module? The module is EC2 instance. What is that the module, guys? A module is, what is that? EC2 instance. So in the CTC EC2 instance module, so what you will create? You will create the files like main.tf and variables.tf and outputs.tf, right? So whatever the module, so this module, so in this module, you can use this module and you want to build a application. So for example, what application you want? So you want a application like we need a three EC2 instances. So we need to build the three EC2 instances, right? So one is for Apache, other one is for Redis or RabbitMQ. So one is for RabbitMQ, one is for ELK logs. What is that? ELK logs, Elasticsearch logs, right? We needed three EC2 instance, but the purpose of these three instances are different, right? So one is for Apache, so one is for RabbitMQ installation, one is for ELK logs. So what is the basic need, guys? We need a three EC2 instances. So we need a EC2 instance. Here we need a EC2 instance, and here we need a EC2 instance, right? So we need a three EC2 instances. So we can create a skeleton. What this is, guys? A model is looks like a skeleton. What is that? A model is looks like a skeleton. You can use this skeleton, and so you want whatever the shape you want, you can create it. Whatever the shape you want, you can create it. So for example, I need a three EC2 instances, right? So I use this instance, I use this module as a resource. I don't want to again to write the main.tf for the EC2 instance purpose because of I will call it this module. I don't want to create the EC2 instances, right? So for this, so after this, so you can call this module as a source, and you can whatever the purpose of this EC2 instance. So for example, this main file contains the installation of Apache. This main file contains the installation of a RabbitMQ. This main file is contains the installation of a ELK. So I can use the main.tf, and I can write the code for the source. What is that? Source is this is the source module, something like a source equal to dot slash module slash EC2 if an instance. So I send instances. So this module will call to the EC2 instance, will create the EC2 instance, then installation of installation of Apache. You can write the code here only for installation of Apache. Here also same, like you can use the this module as a source, and you can create the EC2 instance, and here you can write the code for the installation of RabbitMQ. What is that? RabbitMQ. You can use this as a module. You can use this module, and we can. So, what is the purpose of module? We can reuse the code. What is that, guys? So, we can reuse the code. I don't want to create multiple times for the EC2 instance. I will create a template. That template contains need to create the EC2 instance. Need to create the instance. So for your stack, you can create a whatever we want. Apart from this EC2 instance, I want to create a S3. You can write it the S3. Here also you want a something like VPC. You can create the VPC. You want another SG here. You can create the SG. Right? Reusability. If you use the model, so we can reuse it. So the burden of the writing the code is it reduces the burden of the writing the code, and your main file contains there is no complexity. So as it is as simple, so it will understand very easy. It will understand very easy. So every Terraform configuration has at least one module. So no, as it a root module which consists of the other resources defined in this TF file. Okay, so the main working directory, a module can call other modules, so which lets you include a child module resources into the configuration, the consistency, where the module includes the module block like the calling module to the child modules, right? So this is the module. This module will be calling to the main. This module will be calling to the main. and whatever the rest of the thing you created on this module, right? Created on this main file, it will execute. First, it will go to the EC2 module. It will install the EC2. Then whatever you want after that installation, so it will install the RabbitMQ or Apache or the LCloaks, right? So the reusability. What is that, guys? Reusability. So something like a model is in Terraform just as a container for the multiple resources that are used together. Every Terraform configuration is a part of module. So every configuration is a part of module. So something like so create your own custom modules. So or you can create a Terraform registry. So we can create the two types of modules. What are those, guys? So we can create the two types of modules. So one is so we can create our own modules or we can use so we can create our own modules or we can create so we can create our own modules. These are the own modules or you can you can get it from the Terraform registry, right? So Terraform also provides the it modules. If you want, you can use those modules, or if you want, you can create your own modules and call those modules, right? So modules will be created under our own directory or something like we can create in the S3 bucket or we can create in the bit bucket or we can create in the GitHub, wherever. You can call that source. Source will be GitHub. Source will be local. Source will be S3 bucket. Source will be bit bucket. Source will be GitLab, right? In the source, you need to mention. So the module will call from a local or module will be called from Bitbucket or module will be called from GitLab or module will be called from S3 bucket or module will be called from so GitLab also, guys. Guys, now you understood a Terraform module. So reuse modules across different environments, either dev, prod, etc. So we can use the module. Guys, understood? Guys, understood or not? So what are the benefits if we use the module? What are the benefits, guys? We already discussed one thing, right? So what is that? Reusability. Reusability. So reusability means we can use the code across the environment, right? Use the code across across the environments, right? So the next organization. What is that? So organization. So organization means keeps infrastructure clean and readable. What is that? It will create a organization way, right? Keeps keep infrastructure clean and readable format. So readable format. Next one is scalability. What is that, guys? Scalability. So what is the scalability? Easily manage a large infrastructure with multiple teams. Right, guys? Easily manage large infrastructure with multiple teams. Multiple teams. And isolation. What is that? Isolation. So what is the isolation means? Test modules independently. So before using in the production. What is that? Test modules independently before using it in production. So before using it in production. Guys, now you understood? So what are the benefits of Terraform modules? Reusability. You can create a organizational way, the structure, and it's a scalability, and it's a isolation. It is a isolation. Guys, understood? So the use of modules in Terraform. Okay. So the use of modules in Terraform. The structure looks like how the structure looks like. So what this is, yeah. So this is a AWS batch 54. In the batch 54, you created a module. So in the module, you created a folder called it as a EC2 instance. So in the EC2 instance, you created the main and everything. So in this AWS batch, same like as a module. In the module, you can create your main.pf. Just to simple the code. So you can write the simple as it is. So main.tf and outputs.tf. What your code looks like? Your code looks like outputs.tf. What is that, guys? Okay. Outputs. No need variables. We already declared the variables, right? Providers.tf and oceans.tf. Okay. So what it contains? A main outputs provider.tf and the versions.tf. So variables we already declared here, right? If you are using in your main S3 bucket, you want to create a variable in the variables in the S3 bucket information in the variables, you can create a variables also. Okay, just I'm creating a EC2 instance with the modules. So I can show you how to create a EC2 instance with the modules, guys. Guys, now you understood? Yeah, okay. The structure should be like I already show you, right? So Terraform module, AWS batch, so 54, right? The batch is 54. So in that batch, I created a directory called as a module. So in that module, in that modules I'm creating. So I'm creating another directory as a EC2 icon instance. So in this directory, yeah, I'm creating so the files called as a main.tf and outputs.tf, uh, variables.tf, right? So this is my structure. So this is my module, right? In here, So in here, so you can create a file called as a main.tf, and here you can call it as a output start.tf, and output.tf, main.tf, output.tf, provider.tf, version start. Guys, now you understood. So your, what is that, guys? So your modules looks like your module look like this, guys. Your modules looks like this. You understood, right? Right. So this is your Terraform module. How you are creating your modules. I will show you guys how to create a module. So what is it, guys? Close the editor. No? VS Code file. Open a folder. Right. So what file we will create? We will create a file like Terraform module AWS batch 54. What is this, guys? This is the module. Okay. So this is your directory, and you can create a. So you see, right? If it is if you want to create a file, you click here. If you want to create a directory, you can click here. What is that? The modules. So in the module, we need to create a directory called as a, sorry, this is modules, guys. Modules. So in the modules, you need to create a directory, call it as a EC2 instance. EC2 hyphen instance. So this is your directory, guys. So in this directory, you see, so when you click right, so where it will be creating, it will be creating a, so Terraform module AWS underscore batch 54. Right. Here I'm creating main.tf, provider.tf, oceans.tf. Right. The main providers and the output start tf. Guys, understood? So you created these three under the Terraform structure. These three under the Terraform structure. I want to create a a files within the modules. In that modules, there is a EC2 instance, right? In that EC2 instance, we need to create the module files. The module files looks like main.tf, variables.tf. You see here? So it's a module to EC2 instance. So variables.tf. So what is it here? Outputs.tf. We create it outputs.tf, and here we create variables.tf. right? This variable under the EC2 instance, we have a main.tf, outputs.tf, variables.tf, right? In the Terraform, what you have a main.tf, providers.tf, variables.tf, and versions.tf, right? So versions.tf, variables.tf, and providers.tf. So we have already configured, right? That we have already configured. Yep, one second. Again, VS Code I'm taking again. Yes, code in the VS Code, open a folder on the desktop. What is that? AWS with DevOps with, I think. Yeah. So here, so we already created the main.tf, output.tf, providers.tf, variables.tf, and oceans.tf. Okay. So what I can take these examples. So versions.tf we already created, right? The versions.tf. So this is versions.tf and providers.tf. What is that? Provider.tf. The provider.tf. Which provider we are using, guys? So if you want to use multiple providers, you can use it. Or else, just I'm using. So provider. What is that, guys? I'm just using the provider. Wait, yeah, I will tell you later. Okay. So this is providers. Yeah, this is provider. This is versions. I think so. We don't need variables. So we just rename it to output start here. Right. So in the output start here, I will specify it. I will specify this. So in the main.tf outputs providers we discussed, versions we discussed, right? So versions and outputs we discussed about it. So in the main.tf, in the so main.tf, so what we can add module. What is that? So module my what is that, guys? Module in underscore my EC2 instance. My EC2 instance. I'm opening this and closing and source. I already told you, right? So we need to specify the source, guys. Source equal to double quotes dot slash modules slash EC2. So modules as EC2 hyphen instance. So instance, this is the source, guys. My module source is this is AMI. So what is the AMI, guys? AMI we can take as a your own AMI. We can take as our own AMI. Right? So what is the AMIs you have? Launch template. We need Amazon Linux tool. For example, this is the AMI. Which AMI you need, guys? We need a this is the AMI. So this AMI we need AMI in the double quote. AMI in the double quotes, right? This is the AMI, and so you can provide the instance underscore type equal to T2 Micro. What is that, guys? T2 micro, right? So instance name, instance underscore name equal to my first module EC2. My first module EC2. Understood, guys? So what is your instance name, instance type, and AMI? So you are using AMI, instance type, and instance name. Instance type and instance name. Right. In the providers block, what you want to use. So in the variables block, we are in the versions we already used. Right. In the variables block. So what we can define in the variables block. So we can define in the variables block. So what we can define, guys? So we want to define versions. So versions providers variables. So what variable we want to define? We want to decide to variable AMI, variable AMI, and description description equal to EC2 instance type equal to string type equal to string. So this is one variable. In the remaining variable same like as right. What this is? So this is a instance type. Instance type description. So description is to instant type. What this description is? This description is AMI ID. What is this, guys? The AMI ID purpose. An instance take the instance type purpose. Another instance name. Instance underscore name. This is related to instance name. The name tag for the instance. So name tag for the instance string equal to type equal to string. Okay. So these all are the variables we declared in the variables. Mains we declared in the main we need to declare, right? So what is the main file? So main file. So in the main file, what we can declare? We can declare resource, resource, AWS underscore, AWS underscore instance, AWS underscore instance. This is web1 instance and open close AMI equal to var dot a, right? Instance 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 type equal to var dot instance underscore type. Next tags. What are the tags we need to give? What are the tags? Name equal to var dot instance dot that instance underscore name. That instance underscore name, guys. So this is the tag value of the name. So as much as possible, here we simplified the code as much as possible. So we simplified the code here. We simplified the code here, and in the variables we declare the variables, right? In the main we declared the how we can take the input and the outputs. So what is the output, guys? In the output, what we need output instance. So instance underscore ID colon open brace close brace. So write value. We need to provide the value equal to AWS dot AWS underscore AWS underscore instance dot web1 dot ed. So this is the ID. It will display the ID of the instance. It will display, guys. The ID of the instance will be display. So this is nothing but a module, guys. So now we can call it. So what can we created a main. So this main will call it to the EC2 instance. In the EC2 instance, what it will create the AWS instance and variables. So it took the variables and variables will be provided under the main, right? What are the main? We call it as a main, and the outputs will be called in the terminal. Guys, understood? So this is the module creation, new terminal. So what is this? Power cell. I don't want a power cell. New terminal. I want a git bash, git init, initializing the git, initializing empty git repository. These are not saved. What this is? File, save all. File, save. Sorry. Terraform init. Missing required argument, line number one, module myec2. The argument source is required, but not definition was found. So what is that? Main.tf module myec2 instance. So this is web1 AMI var.ami instances, var.instances, tag var.instances. So what is that? Module. What is that, guys? Main module. What this is? Main module. Main module, right? So the main module myec2 colon source equal to yep, yes. So source equal to module instance. Next time. Yep, yes. Initializing. So the module. So if you are trying to create a my EC2, right? In this EC2, first it will call to the source module EC2 instance. In the source module EC2 instance, there are the main.tf, output.tf, variables.tf. So once it is called, so in the main.tf, we can take the AMI. So AMI will be getting it from the AMI. So output provider also we can provide the Yeah. So the Terraform has been successfully initialized, guys. The Terraform has been successfully initialized. So where we need to create the resources? We are not provider, right? So in the provider or in the variables, we can declare. So here in the variables, we declared the main instance Terraform providers. Yeah, provider will declare the providers will declare region and so we'll declare the in the provider we declare region equal to region equal to US East 1. What is that, guys? Region equal to AWS. So region equal to US East 1 now. Access key equal to will give the access key and the secret key equal to will take the secret key. So what is the access key, guys? For example, access keys and I copied in the notepad. I'm pasting here and the secret key is copying here. Okay. Okay. In providing all these informations, save Terraform in it. Yeah, it is initialized, right? Terraform plan. So Terraform plan means the blueprint. It will give you the a blueprint of the what we are trying to install. Right, guys? Yeah. So one to add. So Terraform apply. So Terraform apply. So what it will create? It will create the EC2 instance. So what is the EC2 instance? My EC2 instance web1 will be created. So web1 will be created. Let's say S. You see, guys, if you use the resources, if you use the resource and created the EC2 instance, if you use the modules and creating the EC2 instances, guys, looks good. Guys, understood? Yeah, you see, guys. So my first module EC2 instance will be creating. So creating. So it is running on running. So connect EC2 instance connect. Failed to connect because of security groups. Okay, so we will enable it, guys. No worries. So because of security group only, so we will set that VPC default VPC and security group. Now you understood? So the instances is created. So the instances is created with the help of modules. Guys, understood? So we created a module called as EC2 instance in the module main output variable. So this main, so something like you want to create a S3 bucket. You just use the use that resource resource, or else we can check it in the that registry.terraform.info. So guys, no need to worry about it for writing the code. Just go to the documentation. Just go to the documentation. Everything will be provided here, guys. You just guys can take this template and write it uh, whatever you want. S3 simple storage. So AWS underscore S3 bucket. What is this, guys? The resource is, what is the resource? Yeah, the resource is equal to AWS underscore S3 bucket. The bucket name, my T4 batch. Bucket name equal to my TF test bucket hyphen batch 54 batch. Okay, tags my name environment equal to Dell. Right. You are trying to create a you are trying to create a EC2 instance and S3 bucket. Okay. So S3 bucket we can create it from your own, and the module EC2 instance we can create from through the modules. Let's see. Let's see. Terraform apply because of we already planned, right? So if it is asking in the apply what you are trying to install. You see, guys. So one to add, the one to add is nothing but a so S3 bucket. AWS underscore S3 underscore bucket dot my 54 batch bucket will be creating. Okay, I'm pressing yes. You see, guys. Yes, three. S3 bucket. Yeah. My TF my TF test bucket dot batch 54 is created. Right, guys. So I'm creating I created the S3 bucket. I created the EC2 instance. But the EC2 instance is created through the module, from the module because of, so EC2 is the skeleton for every instances. If you want to install anything or a web server or a messaging queue servers or whatever the servers, just we need a first instance. So if you create the instance, right, it will be reusable from the module. So from the module, don't worry to bother about the creation of the EC2 instance. The regions, everything will be the first you can mention in the module. So we can reuse it in any environment. It is a dev environment, QA environment, or production environment. So we can use it. Guys, understood? Guys, understood the module.
Yes.
Yes, right. Yeah. So what we can, so we have a module like EC2 instance. In the EC2 instance, you provided the variables, outputs, and then so here you provided the what you want. So you can simplify as much as possible. So in our main file, guys. So you can create the module, right? So module will call to that EC2 instance. Okay. So you can use that module in number of times. If you want to use that module in EC2 a dev stack, a QA stack, or a production stack. So we don't have a burden to create EC2 instance again. We can use those modules and we can call those modules and we can install the EC2 instance whenever we require it. Guys, understood? So reusability, organization, scalability, and isolation. So these are the most four concentrations to the Terraform modules. Guys, understood? Yeah. From tomorrow onwards, we'll continue Ansible, guys. So, guys, if you want a class on tomorrow or you don't want, please let me know. So then we can plan it if you want to take a class or if you don't want to take a class. So my suggestion is yesterday, so that class was not happened, right? That's why I'm thinking to take a class on tomorrow's class. Okay, so if you guys are comfortable with that on Saturday. So we'll take the class. Siri, Meghna, what you guys? The same like 6 to 7. So we can prepone or postpone or whatever the feasibility time you can specify that time and we can plan it accordingly. Okay. Yep. Thank you.